Hello everyone, welcome to the demonstration of our tool COMEX. I am Deepshi Das and co-presenting with me today is Noble Saji Matthews. This tool was conceived and built in a collaborative project between IIT Tirupati India and IBM Research Labs India through IBM's Open Science Collaboration Program initiative for encouraging collaborative research between industry and academia. Our co-authors and collaborators from IBM Research are Alex Matai, Shrikant Tamilselvam, and Atul Kumar, and from IIT Tirupati are Kranti Sedamaki and Sridhar Chimalakonda. If you are a researcher or developer looking for a tool that performs static analysis on multiple languages to generate various code views that can be customized and combined, COMEX is the tool for you. In particular, COMEX is designed keeping in mind researchers working on source code representation learning. Source code representation learning is a domain that has very exciting applications in AI for software engineering. It is the task of effectively capturing useful syntactical and semantic information embedded in source code. Hence, it deals with representing source code for use in machine learning models with minimal loss of important information. Most popular code-related ML datasets, like CodeSearchNet, contain arbitrary method-level data points and incomplete or uncompilable code snippets. This setting makes it difficult to use regular static analysis tools that typically expect compilable code snippets. Additionally, most available tools today that do work in this setting lack out-of-the-box interprocedural analysis and are also difficult to extend to other languages. COMEX, on the other hand, addresses these limitations and hence can be useful for researchers and developers working in AI for ASE. COMEX allows users to easily create and combine multiple code views together. It takes as input a code snippet and configuration, specifying the customizations and the code views to be combined. The basic parsing is done using TreeSitter, which supports over 40 popular languages. It outputs a concrete syntax tree, which COMEX uses to build an enhanced symbol table with type information, scope information, and other required artifacts. This is followed by further static analysis to generate the ASD, CFG, and DFG as required. The DFG is generated using a two-phase reaching definition analysis on the CFG. The generated code views are customized and combined based on the specified configuration and made available in the .json and PNG output formats.
Let us now dive into how we can quickly set up COMEX and demonstrate how easy it is to generate a variety of customized and combined code views. To follow along with this demonstration, please make sure GraphViz is set up on your machine. It can be installed at the page linked in the README as shown here. As COMEX is published on PyPI, you can use pip install COMEX to install the package. Here is a simple Java code snippet that shows a single function to try and find the max of two numbers. For this, let us generate the statement level control flow graph using COMEX. We use the command line interface provided to do this. Enter COMEX help to see the available options on the CLI. To generate our desired CFG, we add the path of the input file to the argument code file. We specify the language as Java, and we specify the graphs argument as CFG. And we let the default output formats .dot and PNG get created. As you can see, the generated graphs get saved in the current directory with the file name as output. Let us repeat the same, but this time for a combined AST plus CFG plus DFG. All we have to do is change the graphs argument. Notice how all three graphs are seamlessly combined in the output graph. For the AST, further customizations such as collapsing can be specified as shown. Even non-trivial Java syntax features such as lambda expressions, local classes, inner classes, synchronized statements, inheritance, construct overloading are supported by COMEX. Let us take a slightly more challenging code snippet that involves interprocedural as well as intraprocedural analysis. Let's generate the statement level CFG plus DFG. Here is the generated output which shows how COMEX handles interprocedural control and data flow. COMEX also supports C#, and here's a quick demonstration on a C# code snippet. If you wish to look into the implementation of COMEX, you can find our repository on GitHub at the link displayed here. Here is how you can quickly set up the tool using the codebase for development and testing. We would also like to note that COMEX can not only be used through the CLI as shown, but also as a Python package within your existing codebases. This can be done by supplying a configuration file and invoking the required code view drivers in a similar fashion. Several examples of how to do this can be found in the test directory of our repository. I hope this quick demo helps you to get started with COMEX. Please do feel free to reach out to us if you have any questions or suggestions. Thank you.